Hi, this video will show you how to make salt from a chemical reaction and also from other salt. In general, method of making salt can be separated into four methods. The first one is precipitation. Second is metal plus acid. Third is metal oxide plus acid or metal carbonate plus acid. And then four, base or metal hydroxide plus. Okay, in this flowchart, I'll make it easier how to make salt by doing like in biology, dichotomous key. So basically, we answer yes and no question on this flowchart. First, for example, if is the salt of our target salt is soluble. If it is no, then we can use method 1. Just mix two solutions of two suitable salt to make the insoluble salt. Then filter off the salt. Then if it is yes, followed by another question, does the metal react safely with dilute acid? If it is yes, use method 2. Add an excess metal to the dilute acid, filter off the excess metal, then crystallize the salt. If it is no, it doesn't react safely, then we'll have another question. Is the metal oxide or carbonate soluble in water? If it is no, use method 3. Add an excess metal oxide or metal carbonate to the dilute acid, filter off the excess solid, then crystallize the salt. If it is yes, if it is soluble, then we can use method 4. Use titration to titrate the metal hydroxide with acid with the acid base indicator, and then repeat the procedure without the base indicator, then crystallize the salt. Okay, let's discuss it one by one. The method 1 is precipitation. So basically this method is suitable for insoluble salt, for example AgCl salt. If you are confused what kind of salt is soluble and insoluble, please refer to the solubility rules. Okay, in here, for example, AgCl salts, this is the target of my salt, for example. Then AgCl is made of Ag+. So Ag+ solution can be chosen from any soluble Ag+ salt. Refer to the solubility rules. All nitrate is soluble, so I just use AgNO3 as my source of Ag+ ions. Then for Cl- ions, any solution that have soluble Cl- salt, like KCl. Then I mix them together with it is either exact moles, or maybe one is limiting, another one is in excess. That's also okay, because the product will be foam precipitate. So chemical equation is AgNO3 plus KCl to form AgCl solid plus KNO3 K plus and NO3 minus is in spectator ion, so total ionic equation would be Ag plus Cl minus to form AgCl solid. So the method would be mix the soluble salt, and then the salt product is insoluble, so we can filter off the salt. So the salt, our target salt, is the residue, so take the residue, wash and dry it, so we can obtain the pure salt. Method 2, metal plus acid. This is the method if the metal can react safely with dilute acid. For example, magnesium, aluminum, zinc, iron, tin, and lead. The acid choice determines the anion of the salt. For example, if you want to make a chloride salt, then we can use HCl. If it is sulfate salt, we can use H2SO4. Let's say I want to make MgCl2, so my choice is use magnesium metals plus Cl source is HCl. So the reaction would be magnesium solid plus 2HClAq to form MgClAq plus H2 gas. Then the method, the acid is mixed with excess metal, so metal is in excess, and then the excess metal is filtered. But now in method 2 you take the filtrate because the product is in filtrate, it is soluble product, and then we crystallize the solution, and then we filter off the crystals once it is formed, and then take the residue, wash and dry it. We continue with method 3. So in method 3, methyl oxide or methyl carbonate plus acid. This is used because some metal, especially for any insoluble metal and metal oxide or metal carbonate, they are insoluble in water, so we can use this method. The metal reaction is with acid directly is not safe. For example, calcium is not safe, barium with acid is not safe, zinc also is not safe, and also any group 1 metal is also not safe to react with acid. Or the metal itself cannot react at all with the dilute acid. For example, copper, silver, and gold. So if we use metal oxide as a metal source, so the reaction would be, for example, for calcium, so calcium oxide plus HCl to form calcium chloride plus water. If it is metal carbonate, so it's calcium carbonate plus HCl to form calcium chloride plus water plus carbon dioxide. Then the method would be the acid is mixed with excess metal oxide or metal carbonate, then the excess solid, either oxide or carbonate, is filtered. Take the filtrate, crystallize the filtrate, and then if crystal is formed, we filter the crystal, take the residue, and then wash and dry it. Last method is a bit different. This is especially for any metals that react not safe with acid, and if the metal oxide or carbonate is soluble, so we cannot rely on the stoichiometry if they are soluble, both of them soluble. So that's why the method is using acid-base titration method. So this is possible for all group metal ions and also the last two group 2 metals. For example, here I'm using NaOH plus HCl to get NaCl. So basically the method is the acid or the base is titrated with each other, and then use the proper acid-base titration indicator, and then straightforwardly write down the volume of acid or base needed to completely neutralize the acid or the base. Then repeat the experiment directly, just add the acid with the exact volume of the base. This volume is we found it during the titration in the previous steps. And then we do this step because indicator in the mixture will be the impurity of the salt. So that's why we repeat it, but we know the volume, how many volume that could neutralize this acid or base. And then the salt product is the soluble salt. To obtain the salt, we can crystallize it, then filter off the crystal, take the residue, then wash and dry it. Okay, that's all of the 4 methods of making salt. See you on the other slide.